I think on that note, we may open things up to some questions. I don't know if we've had some popping through in the chat window or not, but I'm sure Nikki's going to lead us through some of these. And if you've got more, now's the opportunity to put a few more questions in that chat field while we address some that are coming in.
Okay, so the first question actually comes from a gentleman who was not able to attend today, and he wanted to talk about the pros and cons of shunt calibration versus millivolt source calibration. Can you guys elaborate a little bit on that?
Sure, I'll take that one. As I alluded, we do record shunt cal data for a lot of our for all of our low profiles, and we do offer that on some of the other models as well. The shunt cal data is useful down the road if you want to do a sanity check or verification, if you will, on the calibration on your system. Some customers do use that as a form of calibration. The con to it would be that you're limited somewhat to the accuracy of that resistor that was used, and you're kind of relying on I guess it's not any different than the cal data, but usually it's the accuracy of that resistor. We typically perform simulated calibrations here or actual in-rig force calibrations for our instruments and indicators here. But shunt cal can be used. Again, if you need help getting a resistor, I should mention that we do offer our cal resistors as well. So if you are down the road and want to do a quick check, we can get you the resistor if you need something different to be able to do the shunt check on your instrumentation. And again, verify the output from the load cell and ensure that everything's good.
Okay, next question. Muted. Where is the most appropriate place to ground the shield or drain wire?
Well, typically that's going to carry through to where you're grounding your instrumentation as well. Don't typically want to have that connected on the load cell side as well. So it's really going to depend somewhat on your actual installation. Sometimes just going to the case of the instrument or to the same ground your instrument's using is sufficient, or if you actually wanted to go to a ground state, you could do that as well.
Do you offer wireless?
We do have a wireless system available. It's our WTS system. Consists of an acquisition module, and that can be paired with a range of instrumentation options from a handheld indicator to an analog output module to a couple different base station options we have. So yes, we do offer wireless.
Can you explain why WMS does not need a jam nut versus low profile does?
Sure, I can answer that. It has to do primarily with how you're introducing the load into the load cell. With a low profile, being a shear beam design, the gauges are at a similar height, if you will, as to where the threads are in the flexure. So the whole point of using a jam nut on an LP is to preload those threads. So you're going to introduce the load not through specific threads, if you weren't tight, but through the hub face and also a consistent point in the flexure itself. The WMC, again, you're going to be loading through the stud. So you can kind of think that if you had a cal adapter or a pre-installed cal adapter in the LP, it would follow similar behavior or installation practices as the WMC.
Could you explain how to do the proper grounding and shielding to reduce noise?
Well, again, this is going to be somewhat application specific, depending on your instrumentation requirements.
Also, the source of the noise, whether it's coming through the ground potentially, or if it's, I would call it ambient noise or electrical noise due to nearby signals. So I'm not sure we can answer that question now, but we'd encourage that person to call us, and we'll see if we can help them through that particular application.
They're coming in fast now, guys. Is there a rule of thumb for how much zero balance error is acceptable?
Our nominal spec, I believe, is a plus or minus 10%. once you see a drift, so it's 1%, I'm sorry. So 1% would be our nominal spec. I'll have to check on what the exact value is from our repair department when they would recommend bringing it back for an evaluation. But again, as you monitor that, it will give a good indication of usage and potential overloads that occurred.
Yeah, I would just say that to recommend you go back and check the CalCert, see what it was originally, and we can go from there. It's going to vary somewhat depending on the model of the load cell.
What is the class of threads used?
Typically, it's going to be on the low-profile series. It should be a Class 3 thread. WMC should be consistent across the board.
Yeah, I would just say that the data sheet's going to list that thread. We use different classes depending on the capacity. Typically, if it's a lower capacity, it's going to have a finer thread. Typically don't use coarse, but it could go from a class 3 to a standard thread, maybe on a larger capacity. But the data sheet's going to refer to that, and obviously you'd want to use similar type thread on whatever it is you're mating the load cell with.
Can you explain a little bit more about the grounding loop?
Well, the goal is to just keep the ground only on one side of the sensor. If you ground on the load cell body, oftentimes you've now created an opportunity for noise to be introduced into the system. Very rare situations that can actually help reduce noise or provide better grounding. Again, it's going to depend on the application and where the potential sources are coming from and what those sources are. Probably best reviewed on an application-specific basis.
Okay, what happens if you use a softer material as a loading surface?
You could have damage, but typically what you're going to see is some issues with your linearity and hysteresis. We want things to be nice and stiff so that the load cell is the item doing the deflecting. So that's typically what happens if you're not using proper hardness. Again, it's going to work, but it's just not going to give you the best performance possible.
Okay, are there shunt cal values available on every cal sheet as a normal routine, or do they need to be requested at the time of order placement?
For standard product, shunt cal values will be noted on all calibration certificates. From an instrumentation level, if you're ordering a system setup and we are calibrating the load cell and the instrumentation at the same time, and then a shunt cal value would also be noted on that.
Yeah, I will say that not all of our load cells are going to have shunt cal data on there, just to clarify. So if you're ordering something that's not an LP, it'd be best to verify with one of our application engineers whether the CalCert's going to include that shunt cal data.
If a base is used, does that negate the need for preloading?
You cut out a little bit, but I think the question was if a base is used, does that negate the need for preloading? And I would say no. The preloading, again, has to do with the live end of the low profile. What the base does allow, though, for is much easier integration, and you don't need to worry about preloading on the base side. I guess I should clarify that. You can just do a light jam if you want on the base side of the low profile if you have a base on it.
Okay, next question. How do you pick your points for calibrating a load cell? For example, a 10K load cell, 2,000, 4,000, etc.
Typically, on a low-profile series like that, you're going to have 20% points in tension and compression. So it's going to go 5 up, 1 down for your hysteresis point. Other load cells are going to have some different calibration options. The SM series is going to have a standard tension calibration. I believe the WMC is also going to be that way. As you reference the data sheets for those products, it will call out the calibration that would be performed as a standard. I should note that there are special calibrations available, so if your application requires a calibration that may not be standard, please contact us at the factory and we'll gladly talk you through the available options.
Can someone elaborate on how the load cell cable placement can influence the measurement?
Well, anytime that the load cell, or I'm sorry, the cable of the load cell has the ability to impact the force exerted on the load cell, it's going to have an effect on the measurement. Again, that's one of the talking points on the SM load cell, that we want to make sure that that cable is not somehow exerting a force into the load cell or influencing the deflection in some way. You can imagine as you're cycling the load cell up and down and the cable's dragging or hanging on something, it does become a parasitic load path. So again, we want to minimize any impact that the cable could have.
Okay, this is a multi-part question that I've been working with Michael. He's asking about software on the WTS system, the BS-4, and wants to know if our website to link up was something about our website, and does he need to download the software from the website for this to work?
Okay, to use that WTS system, if you're using the base station for this, you would want to use our proprietary software. It is available off the website for download. Once you purchase the product, it is again under the documentation tab under the WTS system.
Okay, this is a long one, so bear with me. He has an application-specific question. He's new to load cells. He has a grab bar that is going to be bolted to the wall and wants to measure how much force a person is exerting on the bar. Is it possible to use a load cell at the point where the bar is bolted, and which one would you recommend?
From what I just heard, I would recommend a very robust sensor. Potentially, you could put that load bar directly onto the load cell and pull directly on that. So I would recommend a low profile, potentially going up in capacity to make sure that it can take the potential side loads or axial loads. But in that case, it's tough to do something like that without introducing a parasitic load path, where you're trying to measure a direct load being applied only to that load cell. So that one's probably a good one to have that person call in and talk with one of our application engineers.
Another one about a grab bar. If I have a 2-foot-long grab bar with 200-pound force at the end of the bar, what force is being applied at the base of the grab bar?
That was 200, really? Yeah. Okay, thanks, Jeff, for that one. All right, so we got a 2-foot-long bar, 200 pounds. It's going to be 200 foot-pound bending moment being applied to the load cell, which is not recommended unless you've got a pretty high-capacity load cell there. So, yeah, I see, Nikki, you put in there, who can stump Ryan and Elliot? I see that's what we're starting to get here. I'm enjoying this.
Are there any advantages to using bipolar plus or minus 5 volt over 0 to 10 volt?
Well, this is going to be, again, a function of instrumentation in the application. If you're looking to measure both directions, then yes, the bipolar would be an advantage. Unipolar, some instrumentation may only function in a 0 to 10 or 0 to 5 environment. At that point, if we were trying to go in both modes, in tension and compression, we would have to be investigating options for a zero offset of some kind, and we do have instrumentation options that I believe we could make work with that scenario.
Okay, where can I find recommended installation procedures and associated torque values? Who's asking about torque?
No, these are all available under the product-specific pages on the website. It should be under the documentation header for each specific product. And as always, if you have any questions about installation of any of these, please just feel free to give us a call, and we can get any of your questions answered.
Do you calibrate load cells with a 100K shunt by request?
We can provide specific shunt cal values. I'd need to check into what the standards are available. I would imagine that if one is supplied, we could also do it in that manner. But again, please feel free to contact us, and we'll run down specifics for you.
Yeah, typically I'll just say that we try to scale. Yeah, typically I'll just say that we try to scale the shunt cal resistors to be about 60% of the output of the load cell. So the appropriate, while we can provide different shunt cal resistor values, usually we have them properly sized for the specific output of that unit to give a good output reading.
How long can the cable be and still use an unamplified load cell? How long can the cable be and still use an unamplified load cell?
Okay, sorry, I didn't hear that initially. You can use whatever cable length you want with an unamplified load cell. However, it's important to know that you should probably use sense or 6-wire configuration and ensure that your instrumentation supports that. There is a slight excitation voltage drop, which we have that information available online if you want to actually estimate that. But again, the point is that if you're using scaling data that's assuming a full 10 volts gets to the sensor, and due to your 300 or 400 foot cable run, it's now dropping to 9.6 volts. It's going to throw off your full scale data there. So that's where a 6-wire or sense solution is the way to go.
What is the usable range of the load cell, and is it linear from 0 to 100%?
That's a question we get asked quite a bit. The rule of thumb is typically 10% capacity, just because you're working with a adequate amount of signal strength that we aren't as concerned over some of the full-scale error influences such as temperature or other parameters. Fundamentally, the sensors will work all the way from 0. They're going to respond. It's an analog device. The problem is that it can often yield to less confidence in that measurement at the low range. But oftentimes we can overcome that with extra calibration points. We're more than happy to do low range points and provide you the actual data on that, which you can then often load in your instrumentation and use that to take out also any nonlinearity concerns too. So it depends. Sometimes it's unavoidable and you need to work in that low range of a sensor, and we do have some options to help you get the best data possible there.
You said that a mounting plate needs to have a 0.0002 inch flatness, but your slides indicate 0.002 inch flatness. Can somebody clarify which one? How many zeros does that actually need?
Apologize, that could have been a typo. We need 2 10,000ths total flatness, 2 10,000ths of an inch.
Okay, this is going back to that 100K shunt. We are performing our own calibrations on site using the 100K shunt. Will linearity and hysteresis be affected by selecting point other than 5 up, 1 down? We do 5 up to full capacity, then back down to 0. Is this acceptable?
Let me take another look at this question here. I'm not sure I'm understanding the question. If you're using a shunt calibration or a scale, it definitely wouldn't be as accurate as probably using the actual cal data. Your second part of your question there says that you do actual points, so I'm not sure what you're asking there. I think it'd be good to call in on that one, and we'll review that again. We talked a little about the pros and cons. You can use Shunt Cal. It's not quite as good, but it is a good sanity check.
150% overload. Does that mean no damage to the strain gauges at 150%? At what overload is there physical damage to the cell?
We would expect the load cell to not suffer any permanent deformation up to 150% of capacity. Past that point, you could suffer some permanent damage to the gauged areas. This would be manifested either by a shift in zero balance or, again, as previously referenced, the RCal shunt value may be different.
Yeah, I want to touch on that. We get that asked again quite often about whether the customer can use that overload range. We really don't recommend it. Over repeated use, it can affect the performance of the load cell. So while it is safe, we recommend you properly size the capacity to be the limit. Because again, we can't guarantee performance. Also, linear hysteresis are guaranteed up to the capacity. Anything above that, you may lose confidence in that data.
Does the 150% apply to all models of load cells?
This is going to be a model-specific question. It's going to be referenced on each data sheet for each specific load cell. Again, the recommendation is to size the load cell so the application doesn't require exceeding the actual rated capacity of the cell.
I do want to say that a lot of our lower capacity minis, which wouldn't be the low profiles, those lower capacity units do have higher overload. So we are aware that as capacities go down, it's often easy to damage a sensor just installing it. So our SMTs, SMLs, a lot of those have 10 times save overload. So not just 150%, but 1,000% safe. Best place to verify that, again, is on the data sheet.
Okay, ladies and gentlemen, we have about 10 minutes left. Last call for questions. Stump Brian and Elliot.
No, I think we're good, Nikki.
Do we want to show off any of our load cells here with the webcam?
Based on what I'm looking at here, we've already got those in the slide. We've just got some SMs here, WMCs, LPs. Yeah, not sure.
Okay, well then we're going to call it and wrap it up. If you have any last minute questions for us, feel free to email us at go2@interfaceforce.com and we will respond to your questions. We have recorded today's webinar and we will make the slides available as well. I want to thank you once again for joining us and hope you have a great rest of your Wednesday. Have a good one.